thanks for that introduction. I'm very excited to be here. It's really an honor. Super happy to connect with you guys and be able to present something here. And as you can see today, I'm going to talk about something exciting, effective Kubernetes for Jakarta EE and MicroProfile developers. And the first thing I want to do is actually show you what we're going to look at today. So we're going to look at Kubernetes, setting up a cluster. We're going to talk a little bit about auto-scaling, auto-discovery, and load balancing. And we're going to talk about self-healing capabilities using Kubernetes probes, monitoring with Prometheus and Grafana, and Kubernetes operators for more effectively managing the application and server clusters. And finally, a glimpse at CI/CD pipelines and a bit more. So before we get started, who am I? I'm David Minkovski. I'm a cloud solution architect, developer, advocate at Microsoft. I am a software developer and a passionate blogger. I love to blog about various technologies, Java, Go, React, DevOps, whatever. In my free time, I like to play the guitar. And feel free to reach out to me on LinkedIn. I would really love to connect. And yeah, without further ado, what are we working with today? Today, we're looking at the average Java cafe. Shout out to the Columbia Java user group and to Reza Rahman's repository. And as you can see, there are two parts of what we're going to look at today. One is the cafe, a CRUD for coffee management, so we can manage our latte macchiatos, cappuccinos, black coffee, whatever we like with the prices, based on an IBM WebSphere Liberty server. And we have a coffee house application, which will order coffee every 45 seconds. And it's a standard Quarkus application that you can generate with one task. So without further ado, before we go on with Kubernetes, let me just show you the application itself so you know what we're talking about. So if we look at the Jakarta Cafe application, it's a standard Jakarta application, nothing too fancy. We have a resource here where you have like your standard CRUD operations. We have our model. Sorry? Oh, I'm so sorry. Wait, but why is it not showing that? Ah, no, it is. Okay, but now it's on that screen. Well, it's fine. So, yeah, and you can see it's a standard model. We have the repository here. Nothing too fancy, okay? This is just our default application. And if we switch back, we want to focus on getting it to Kubernetes. Sorry for the technical circumstances here, but it seems like it's not showing as an external monitor, I think. There it is. So when we look at these applications, we want to get them on Kubernetes. And the first thing when I talk to customers or other developers is they are really happy about it. Yes, let's get it on Kubernetes. We're all excited. It's a fancy new technology. We all love it. Kubernetes is the best. But why? Why are we doing that? Like, I'm sure as many of you, and me myself as well, we are kind of CV developers where it's like, okay, it's a fancy new technology. Let's try it out. Let's do it. Many customers want to do it. But today I want to emphasize why it's actually good to get things on Kubernetes and what the benefits are. So one thing I want to look at today is resource efficiency. You see, when you have a data center with multiple servers, without Kubernetes, you need to manually deploy the applications on those specific servers. And I'm sure many of you are familiar with the headaches with that. It can be really tiresome. And one thing that is important is when you have those applications, you need to actually figure out the resources. You need to make sure that the server is ready. You need to configure it. You need to actually know also the resource requirements and then map it, which can be a lot of labor. But with Kubernetes, you can intelligently allocate those resources and ensure optimal usage, which is very easy because you can just configure it. Another thing which I think is very important is isolation and security. Cybersecurity is one of the most pressing topics up until now, and there are a lot of threats out there, so we need to be aware of it. So one use case is if you're a financial institution that handles sensitive data, Kubernetes provides a way to isolate these applications because we're using containers, and each application runs on its own with its own set of permissions. You can use role-based access control, network configuration, secrets, all kinds of stuff to make sure that it's really isolated and secure. Role-based access control helps you to make sure who is in charge of the cluster, who can do what, and that is pretty awesome. Now, another thing I want to look at is high availability. Can you imagine that you're in charge of a healthcare system where downtime is not an option? I think that's really, really important. Well, with Kubernetes, you are ensuring that if a server or container fails, the application quickly restarts on another node, and thus you're minimizing downtime. And that's really awesome. And it does it on its own. You don't need to worry about it. Another thing I want to look at is scalability. I mean, we can imagine, right, we work for a big corporate or some very large e-commerce platform, and we're happy. Christmas is coming along, and we're going to experience a surge in traffic. Great. Well, you don't need to worry, because you don't need to call your developer up at night and, be ready, because Kubernetes allows you to automatically add more resources and to handle the increased load. And why will your managers be happy, or any manager actually for that fact? Well, after the event, it scales back down to save costs, all automatically. Pretty great. Another sentence I think everyone knows is, it works on my machine. I've said that a million times, I'm sure you guys know it too. Software development teams where each developer can actually have their own cluster on their local machine, and I'll show you how that's done. You can develop, you can test, and you can debug everything and mirror production or staging or any other environment. So you can make sure that if it works on your machine, it actually also works on others. That is a huge advantage. And last but not least, future ready. I mean, there are companies that are running on-premise, and that makes sense because of regulatory reasons and many others. But at some point, you might see potential to move into the cloud, and that makes perfect sense. But if you are smart about it, you can use Kubernetes already today on-prem, and you're preparing because the transition will be super easy. If it runs on-prem on Kubernetes, it's going to 100% run in the cloud. For example, on Azure Kubernetes services. So I think we all know why, and that's why we love Kubernetes, and that's why it's an amazing solution. Now, what I want to look with you at today is, yeah, we're ready. And I experienced this with many developers and customers. They say, yeah, I want to get things done on Kubernetes, and I want to start it right away. Well, but how are you going to do it? Like, how are you going to do that? It's not that self-explanatory. I mean, Kubernetes is a pretty complicated technology. And as a developer, as a junior developer or any kind of company, I would be like a little bit, how am I going to start? So there are 3 ways. But before we go into those ways, I want to tell you, we have an amazing repository up and running on aka.ms/java-k8s, as in Kubernetes, where you can try out those things yourself. And you'll be guided step by step. So if you're scared at first to try out Kubernetes and Java, there you go. You type in the URL, you get the project, the repository, and you'll be guided. We have different folders here: clustering, DevOps, monitoring, operators. Big shout out to the Colombia Java user group and Egypt Java user group, and also Reza Rahman's repository, where you can just check out the stuff yourself. So one of the 3 ways of setting up a cluster is Docker Desktop. Amazingly easy. You can just go on the website, install the Docker Desktop client, and get it running. I'll show you in a second. Another way is using Minikube. And the third way, if it's really, really easy and convenient, is Azure Kubernetes Service. So you can just start for free and have it up and running in the cloud. Now, I want to show you how it's done using Docker Desktop. 1 second. I just want to make sure that I have it here. Can you see my screen? Oh, okay, perfect. 1 second. There it is. So if we open up Docker Desktop here, you'll be able to see, okay, I have a local registry up and running. But if I go to the settings, right here, and I go to Kubernetes, it's one check. So anyone who says Kubernetes is complicated, it's not. You can be a total newbie, a junior developer, you just download Docker Desktop, you check this item, enable Kubernetes, you click on apply and restart, and you have your Kubernetes cluster running. Now I can show you actually that I have a Docker Desktop client. Second. There it is. So my current context is Docker Desktop. Now, everything all right? Or is it too small? Oh, it's good. Okay. So another thing that I want to tell you about is container time. Oh, thanks. Container time. So anything that can be containerized can run on Kubernetes. Anything. And by that I mean any technology we know can run on Kubernetes. You can simply use a Docker file, you can build the image, push it to a registry, declare the deployment file, and then you can start it on Kubernetes. Lucky for us, we don't even have to worry about Docker files anymore. I'll show you. If we check out the code again, you'll see here that there is a Docker file right up there that is already there. Now, how cool is that? This is a WebSphere Liberty Docker file, which you can use. The WebSphere Liberty Docker file is on the Docker Hub. And we simply copy what we need, the PostgreSQL jar. We copy the server XML, the configuration, and the WAR file. That's all we need to do. If we containerize this application, it's going to run immediately. We can push it to our local registry, and that's it. So speaking of local registry, when you have a container, some people might ask, what's a container? So how do they differ from VMs? So a big difference is that unlike virtual machines, they require a full operating system for each instance. Containers, they share the host OS. So they're super lightweight and efficient. And containers are like self-contained lunchboxes. That's how I like to think of them. And when I talk to customers, that's how I explain them. Each lunchbox is unique. Yeah, you have your meal, your utensils, your napkin. But you can package them and just put them in a lunch bag, and they'll work. You don't have to worry about them. You just take them with you, open them up again, and you're good. So when you do that, you can actually run your own registry with one line of command. I showed you the registry already. And this registry will be there to have our container images inside. And all those container images that are in the registry can then be used to actually run in the cluster. So it's that easy. One line of command, you have the registry running, and you're good. Now, one question we'll have is, we need them to talk to each other, right? When we develop multiple services and applications, they usually talk to each other. That's how microservices work. Well, I don't know if you're familiar with that, but from my experience, you need to get the IP of the other service. You need to update it, store it, you want to communicate with each other, and that can be a hassle. That can be a real nightmare and a headache. And if you're not using Kubernetes, yeah, that's difficult. Well, I want to show you something else. And here we go. In our project, let me just bring it up to me and then show you again. If we go to our Quarkus application, for example, one second. You'll notice that in order to call the REST API, I'm not using an IP here. What I have here is the service name. And the great thing about this is that Kubernetes allows me to call different services using their service name. And even though they might run differently in different environments, this will still work in any cluster. This is actually how they talk to each other. Now, if you also use a deployment, Kubernetes deployment file, you can also use the service name to actually connect to the database. If we look at that, we'll see how that works. And that is auto-discovery for seamless integration. That's what Kubernetes comes with. Now, the great part about the service discovery is it simplifies integrating microservices drastically, because you don't have to take care about them finding each other, communicating with each other. You just need to provide the right service name, and they can communicate. because it maps the service names to the right services and thus to the right pods. And that's all going to work just via the name. I mean, that's super easy, right? Now, we have managed to actually connect those services. It's all working. We're up there. But yeah, you can see the traffic increases. And we're scared because it's a good thing. We're happy, but we need to actually control how many instances there are, what if we need to limit the number, and how do we run more apps? I mean, that is kind of complicated, right? Well, with Kubernetes, we have auto-scaling for efficiency, which is pretty awesome because we can dynamically adjust the resources and thus ensure the optimal performance while reducing the costs. How do we do that? Well, we can use the auto-scale, and we can even configure that there's a certain amount of CPU percentage threshold, for example, the minimum amount and the maximum amount of pods, and we're done. We don't need to worry about that stuff anymore. Now, another thing I want to show you is that you can also take manual control. Now I'm going to show you that if I go to the application, you'll see I have 3 deployment files here. First thing I'm going to launch is the database. Another thing I'm going to launch is our Jakarta Cafe application, and also the coffee house for fun. Okay, all up and running. Now let's check this out. kubectl, get pods. We see it takes some time, we can watch. And they're running up. Now, if we want to look at the deployments, we can simply do kubectl get deployment. And you'll see that we can actually see all those deployments. Now, 1 pod is not enough, but that's what I specified, right? But I know that there will be a huge traffic spark soon, and I want to actually adjust that and scale it up. Well, how am I going to do that? Well, that's pretty easy. If I'm not specifying the amount of pods, I can do this. kubectl, I hope everyone can see it. Is that better? Scale, deployment. I can provide the deployment name, for example, the Jakarta Cafe, and I can provide the amount of replicas, let's say 4. It's scaled, just like that. Well, probably you won't believe me, I get it. So let's take a look. There it is, 1 out of 4. So if we now take a look at the pods, we'll see that it spins up all those pods just like that. I mean, how easy is that? It's 1 line of command. Crazy, right? And that is me being in full control of my deployment. This is not the auto-scaling. This is just me manually wanting to adjust it. And because I'm in a happy mood and I want to get some coffee and the traffic went down, I'm just going to be like, yeah, we can go back to 1. It's fine. And again, terminating. Kubernetes takes care of it for us. We don't need to worry. Now that we have seen auto-scaling, another thing I want to talk about is load balancing. You see, one thing that we need to usually take care of is the entire idea of distributing load, right? We need to make sure that we are responsive, that our traffic is served correctly. Well, for that, load balancing. Load balancing takes care and distributes the traffic amongst the pods and improves thus the application responsiveness. And creating a load balancer is so easy. You can just expose the deployment, provide the type load balancer, or configure it in your Kubernetes deployment file, and you're good to go. And you have your load balancer ready. This way, you can make sure that your users actually get responsive applications. I think that's pretty awesome. Now, today, it is all about MicroProfile as well, right? I mean, we've been talking about Kubernetes a lot, but how does it fit in with MicroProfile? Well, MicroProfile has a standard specification for health. And this endpoint, it fits perfectly well with the self-healing of Kubernetes. Kubernetes self-healing detects and recovers from pod failures and enhances reliability. And how does that work? Well, it's pretty cool. It's a little bit like a chat buddy. Kubernetes talks to each application all the time, and it's just asking them, hey, how's it going? Are you still there? Are you good? Are you all right? Are you ready? And we don't have to take care of that. We don't need to actually manually check out the pod and see if it's still running. It's just a dependency. You have the endpoint,
and it's good. Now, what is great about it is that we can also provide those endpoints ourselves. I will show you. If we take a look here in the code, 1 second, we will have we'll have a Kubernetes deployment, and in here you can see that we can provide readiness probes and liveness probes. Now, why is that important? First of all, because then we are in control. Yeah, we can always specify the path of where we get those information. We can actually say, okay, there is a delay, timeout, periods of seconds, and obviously different applications have different endpoints for the health. For example, in Quarkus default, it's with /q/health, and so you can basically adjust it yourself, and you're in full control of how the self-healing works. Let's go back here. Now, okay, we've seen self-healing, and I'm going to show you some of the code later on as well, and we've seen also the other topics of auto-scaling, but I don't know how it is with you, but I'm always very skeptical about stuff that is running. Also in the cloud, on-prem, I don't care. I want to be in control. That's a thing, right? We as developers want to know what's happening. So we want to know how much memory is consumed, how are the response times, what is happening to the CPU, and other metrics. We want to know all that. Well, how do we go about that? Do you guys have any idea? I'm here to help you guys. I'll tell you. The solution is we're going to monitor. And monitoring for insights has never been easier. Prometheus and Grafana. And again, it plays hand in hand with MicroProfile, because we have the metrics endpoint, thus we're receiving all the data and information we need. And if we use Prometheus to crawl that information and Grafana to visualize it, it's super easy, right? Let me show you. If we take a look at, let me just do it with the terminal, it's a bit easier. Ah, nice, finally. Okay, so if we go here, you'll see in the project as well, you'll have a monitoring folder. Can you see it? Yeah, perfect. In this monitoring folder, you'll have a default Jakarta Cafe dashboard, fancy name. And in here, you'll see that what we're doing, next to a bunch of other stuff, is we're configuring a deployment file for Prometheus, which we're launching from our own Docker registry. Because our registry lives at localhost 5000. This is our Prometheus image, because we want to be in control. And we have a load balancer here, and another deployment, which is Grafana, so we're instantiating Grafana. Now, what's really cool with Prometheus is we can actually provide it with Kubernetes targets. So we can say, okay, I want to have all pods that have a certain label, and I can even specify the path to the metrics. Why is that important? Again, we want to be flexible, right? We don't care. Anything we can put into a container, it will work. So we can provide the endpoint of Q metrics, or metrics, and thus get both. Now, it's pretty easy. Let's go back. And what I'm going to do now, I just want to show you so you know it's not magic. I've got all those images stored up in here, okay? I built them. And you can just use a Docker file to build the Grafana, Prometheus, Coffeehouse application. I can show you later as well. And then we can simply go to the monitoring folder, hit kubectl apply, our magic command, and watch Kubernetes work, which is my favorite part because I don't have to do anything. I'm a good developer, I'm lazy, okay? That's how it works. So now you can see we have the database running, we have Grafana, we have the Cafe application, we have Prometheus and Quarkus. Let's take a look again at the services so we can see actually the ports. And one of my favorite parts about this is the control over the metrics. What I really like to do is to visualize things myself. So first thing we're going to do is check out our WebSphere Liberty application, which lives here. Woo, fancy. That's a crud. And I'm in the appetite for some cappuccino. Oh God, I don't know how to write it. Bear with me. I'm going to submit that one. And some black coffee. The prices are great. And maybe another one. You'll see in a minute why I'm doing that. Okay, now these are all stored. And I have my other service, which lives here. It's a Quarkus application, nothing fancy. I generated this one. And I created one order task, which does nothing more than ordering coffees. And that does it very simply. I'll show you the code. It is a very simple task. It gets the information from the Jakarta coffee house. It gets all those coffees. Then it randomizes it, and it actually carries it out. It prints it, nothing fancy. However, one thing you might notice here, which is a bit special, is I'm using a meter registry. So I'm actually having a counter here on my coffee orders, which is a custom metric I'm using, which is business logic. Now, how does that look like? Well, let's go here and see the metrics. So I have access to all the metrics of the application, but also, after 45 seconds, you will have to wait, we'll also see a coffee that is ordered, which is here. So if we go to our Grafana, to our Prometheus, I want to show you. Hold on 1 second. Where was that? On port 9090. We should see here the targets. Magic, right? Pretty cool. Now let's combine it with some previously introduced magic, which is the scaling, because we're afraid of our amazing Christmas traffic. So let's scale it up. I'm going to have 4 replicas here. Now, you can't tell me that this is going to automatically show up in here, right? I mean, that would be too crazy. Well, it does. Magic. So all the metrics, because it is using the same labels, Prometheus is automatically getting those targets, getting those metrics, and providing them to my favorite toy, Grafana. Now, let's check out Grafana. There it is. And in Grafana, if you check out the repository, you'll find that there is a dashboard already there that you can use, which shows you that you can see actually the CPU, the memory, the rest, anything you want. But where's the fun in that? I want to create my own dashboard for something very useless, because that's fun. So let's do that. We're going to add a visualization using Prometheus, and I'm going to take a pie chart right here, and in here I can select my metric, and here is my counter, which I registered before. Coffee orders total. Now if I run this query, we'll see I have my pie chart. Isn't that great? I can just use that metric. So I don't need to only use Grafana and Prometheus for some server stuff, but actually also for business logic. I have my own dashboard and I can visualize whatever I want. And that's pretty easy. Now I want to adjust the legend a bit because I don't like the way it looks right now. There we go. Apply. There we are. That is pretty cool. And that was really easy. Now, one thing I want to show you is that if you look at the deployment files, you will also see that I can use that also for the dashboard and for the database. So my Jakarta coffee here has, as we know, the environment, variables, but you will see here that I don't have a real host provided, just the service name. Again, this is possible because of the auto-discovery, which is really cool, because that means that as long as the service name is the same, I can use different databases, I can use different clusters. This will work on production, on staging, on any type of cluster you want. And that is very easy. Now, here I want to show you again also the endpoints, which changed because I'm in full control of the health endpoints. So, what we want to look at now is, what if we have a very highly complex database system,
like super complex. I don't trust Kubernetes with like finished images or whatever. I have my own stuff and I need it to work, and it needs specific configuration like replication, backup, scaling, and it's a lot of work. I need to provide all of that myself. I need to create those services, the deployments, the configurations. Can be tough. That's a nightmare, right? So lucky for us, there is something magical called operators. And these operators are there to automate complex application management tasks for us. You see, other companies are just going to provide us with everything we need. And you can imagine, I like to explain it a little bit like a plugin. You see, because it uses the Kubernetes API underneath, but it provides you with anything that you would need. And also, lucky for us, I'll show you that there is also a WebSphere Liberty operator. So if we take a look here, you can see the operators also again in this repo, where we're using this customization, and we're using a custom resource definition, which you can use yourself. So you can also build your own operators and provide them with a bunch of stuff. A bunch, as you can see here. Full flexibility, but crazy. And the cool thing is you don't need to worry. There are so many operators out there that you can 100% find yours and then never worry about that stuff again. I remember that there were a couple of other talks that mentioned that as well. That's pretty awesome, I think. Now, another thing I want to talk about is, what if you want to run it in the cloud? Well, there is something very simple for that, which is Azure Kubernetes Services. And a lot of people think that that's complicated and that it's very difficult to run Kubernetes in the cloud. Well, actually, it's not. It's so easy. You can use the Azure CLI and one line of command, and you have your Kubernetes cluster. Okay, not entirely. Okay, it's not just one sentence. That would have been amazing. We will get there. But you can be cloud ready by using just 3 resources. So if you want to get Kubernetes up and running and you want to have the hassle and you just want to have it in the cloud, you can have 3 resources that you can create which will help you to get it up and running in no time. First thing we need is the container registry, which is very important because that's actually where our images will live, okay? As long as you want to use an image on Kubernetes, you need some registry to pull the image down from. Then we have our Azure database for PostgreSQL, which is our database, because we don't want to take care of that. We don't want to scale it, all that stuff. Let the pros handle that. Managed database is a good option. And then the cluster itself, which you have seen is one line of command, or you can use the portal. It's quite easy. You don't need to configure anything else. Now, when you do that, you'll need an ingress. Yeah, that's one copy-paste, but why do we need an ingress? Well, it's basically a traffic hop for your applications. You see, when you have multiple applications and you have different places inside your cluster, you want to make sure that the users can access your services. And for that, you need an ingress to expose it to the internet, which is basically one main entrance, and it manages all that traffic for you. So as you can see, different domains, different services, and that's how you get them to the pods. Okay, so it's like one central thing that makes sure that your applications are safe. It handles the encryption for you, and it makes sure that each visitor gets to the right place. That's basically why you need an ingress for. Now, we went to the cloud, and one important thing in the cloud is CI/CD pipelines. I think everyone agrees that this is what saves it up in the end of the day, because you want to implement continuous integration, continuous deployment, and that is so easy with Kubernetes in the cloud. Because what you can do is you can create a pipeline, I'll show you a workflow file in a second, that builds your application, it tests it, it deploys and pushes the image to the registry, and then you can just remote control in the cloud, get the Kubernetes deployment up and running, delete it, apply it, push it, and that's it. So super easy, because again, we're running with containers. I'm going to show you now. Again, in the repository, if you check it out, you'll see that there is a GitHub
workflows file, which is your main YAML. And essentially what you need to do is there are a couple of steps, okay? First thing you need to do is you need to log into your cloud provider, in this case Azure. You log in using the credentials, which you can store in your GitHub as secrets. I mean, that's kind of best practice. And then you can make sure that you set up all your build. You can then delete the current deployment using kubectl. And then you just build your image, you package it, and you push it to the registry. And then you can, again, apply it. So it's super easy. As long as you can make sure that your application is containerized, you push it to some registry, you can then use Kubernetes deployment files to access those images, pull them, and deploy them. So essentially, if you want to go on the cloud, you have one difference. You can use the same deployment files, but you need to be aware of two things. One, you need to make sure that the image provided links to the right registry. It can't be a local one anymore. So, for example, here, right, I'm using the Azure CR, the Azure Container Registry. And you will probably need an image pull secret. What is that? It's actually a way to make sure that you are authenticated against the registry, so you are in the rights to pull that image and to launch it. That's how it works. Now, that's all you need. Essentially, everything else is the same. When you're looking at the Jakarta application, I just want to show you one more thing. When you deploy it to the server, you have one Docker file, as I mentioned. You copy the stuff, like the XML, the WAR file, you package it, and then you can deploy it because you're just pushing the Docker file and pulling it again from the registry. That's all you're doing. So it doesn't matter if you're in Quarkus, WebSphere, or any other application server. Containerize it, push it to the registry, pull it, and you're good. Expose the metrics, expose the health endpoints, so you're actually using what is important in Kubernetes, and set up auto-scaling, and you're good. All these things combined make sure that we run Kubernetes like a boss. So, yeah, thank you. I want to say at this point, please try out this repository. Again, go to aka.ms/java-k8s. You'll be guided step by step. Each folder has a clustering example, monitoring example, DevOps example, and so on. And feel free to experiment with it because it's really fun, it's cool, and it's very easy. Thanks. Any questions?
Thank you, David. Questions? None.
Then everything was clear.
There's one over there at the end.
Oh, okay.
Thank you for your talk. If I understand, I have a question about the automatic service discovery for Kubernetes. If I understand correctly, it does this discovery on, let's call it on abstract level, coarse grained. So it discovers the service exposed by some containers. Do you think it also provides some fine-grained discovery? For example, it can discover some API exposed by some Java application or like it's Java API, Java package. So another container can discover this Java API and use it instead of using endpoint. Instead of using REST API, it directly uses the class loader to load the class and use it. Does Kubernetes support this?
That is an excellent question. I'll be happy to take it with me, research that, and get back to you.
Thank you. One more, is that okay?
Sorry?
One more question, sorry.
Yeah, sure.
Yeah, okay. It's about, mentioned we can monitor the results using Grafana. In addition to monitor the results, it's possible also to control the results limit. For example, we can control the CPU memory for a container on Kubernetes. If the results exceed some limit, either reduce its priority or stop it or whatever. Does Kubernetes support these features?
So what you can do is you can decide on the scaling with the auto-scaling function, where you can say, okay, a certain amount of CPU and so on. The other thing you can do, which I didn't show, is you can also configure the amount of resources you need for a certain application with resource requests. I'm not sure about the naming. And this way you can control which application gets what resources and also scale based on that. I think there was someone else with an answer too.
Yeah, no, it's actually you can put on the deployment resource limits like X amount of RAM and CPU, and if it gets exceeded, your container will get killed. So you will not have a runaway container, but it will kill. You also have the scaler, as he just mentioned. So when you get above a certain load or memory usage, then you can scale out to have more replicas, so more pods running in parallel, and the load balancer would then distribute the load over all of them. So it's two different kind of things. And for your first question, the microservice idea is that all these services are standalone, between quotes, and the registry works by give every service, you give it a name. And then in Kubernetes, you also have these namespaces, which are like package names in Java. And if you run in the same namespace, then you can find a different service by just this short name that you gave to the other service. So you call one service coffee house, and the other one you call order service. And so the order service just talks to coffee house, and Kubernetes knows, okay, it's in the same namespace, so it will talk to the other one. But this is always HTTP or gRPC or whatever kind of remote communication. So you can't really load a class from the order service into the other one and then do fancy stuff within the deployment. The base assumption is that your images are immutable. So what you deploy is an instantiation of something that is immutable. And when you made a modification, it will not persist, but Kubernetes will or may randomly kill it, deploy it somewhere else on a different node within the same cluster, on a different compute node, and will start it from this original image. So you do not want to make dynamic changes on the fly in a deployed instance of that image.
Hey, you want to keep the mic? I think you're doing a great job.
Okay, so first of all, congratulations for your presentation. It was
thanks.
amazing. I have a little question. Some friends of mine used to ask me, regarding the resources configuration. We used to run a Java application with big memory, because we know that Java uses heap and so on. But in Kubernetes, we used to use the minimal ones. So in your perspective, what is the best to use Java on Kubernetes? To use a small memory, ramp up pods and so on with less memory, or define a good size of memory to use it? I know that it depends on the context,
Exactly.
but
I mean, frankly speaking, the less memory, the better, just generally.
Sure. Right.
But I can't, it depends on the application. With some applications, you would like to have less memory usage, but you can't. What I think is really great in Kubernetes is that in each application, using those resource requests, you can really make sure that you're getting to the machine with the right amount of resources. So you can say, okay, I need this amount of CPU, and it will tailor that. And you can also taint nodes and make sure that applications are not getting on those because, I don't know, they're highly, they need to be reserved for other instances. So essentially, you're in full control of that. Now, if you would ask me, I would have preferred to use no resources at all, always, because that's the cheapest. But I think it depends on the context, like you said rightfully. But yeah, thanks. Great question.
Anyone else?
Yeah, just maybe just a few small comment about the resource. There's, I think, also worth it to look on the watermark pods auto-scaling, because I think what you demonstrated is the HPA, horizontal pods auto-scaling. And I think on experience on a project, it was like more cost effective because it's a bit smarter than the horizontal scaling. I just have a small question about remote attestation. So I don't know if you know how we can verify a Docker image on a Kubernetes cluster that is not been tampered with. But I think the more maybe difficult thing is you can check that assign the Docker image during the build process, but is there a way to verify that the run variables, for example, are not have been changed or something like that?
You know, I actually remember that there was a case with a customer. I really forgot. I think there's even an Azure service that does parts of that. But as far as I know, that is actually a huge security concern in general, because in the end you need to trust on the one hand, because you need to basically, it's kind of the chicken and the egg problem. On the one hand, you need to make sure that certain images are trustworthy. On the other hand, how do you check that they're trustworthy? There are checksums and so on, and there are methods to do that. But at a certain point, I remember I talked to a colleague, it was always risk versus benefit. How much security do you include while limiting your developer experience and also possibilities? So, yeah. But I will gladly take that with me as well. That's a great question. Like checking. You mean Docker Desktop? On Docker Hub, you have mostly official images. Yeah, yeah.
I'd like to make a general but tongue-in-cheek remark on auto-scaling. So if you want to prevent me from supergluing myself to a conference floor here to join the Greens and everything, please, if your application uses more resources than a pod has, before enabling auto-scaling, please check what is using the resources and why it is using the resources. Because I have a bet going on. I say that every application that is unoptimized, I take the bet, then I can speed it up 10 times or improve or lessen the resource consumption 10 times than it does in an unoptimized form if it has never done. And you can do that as well if you take a look why you consume that amount of resources. So please, for the environment and us and everybody, have a look at why you use these resources before you just scale out, scale up, and your credit card will say thank you as well.
Maybe one more comment just in general, because I'm having these conversations with many customers, and this is an add-on to this. This is separate. Kubernetes is not always the right solution. And also, AKS is not always the best choice. There are other services, container apps, for example. Because I don't know if you guys have had experience with Kubernetes, but even after doing like official certification, CKA, reading up the Kubernetes documentation, it's still a lot of work to really know the fundamentals and get everything up and running and configure it correctly. And there are a lot of security concerns to think about and networking and all that stuff. So like I said in the beginning, to kind of introduce this topic, just because it's a buzzword and it's amazing, it doesn't mean you have to use it. Yes, it's great. It has amazing perks. But you need to always be aware also of other things, like, do you have the guys that know the technology? Do you have the people that are willing to put in the time to set it all up, to configure it, to be maintaining it? Maybe there are alternatives, and as a business, it's sometimes smarter to focus on what is important for your business than on the underlying technology just because it's fancy, okay? So sometimes I have startups, AKS, and I'm like, no.
you don't have a Kubernetes pro with you, you don't have someone who knows how to set it up, and I don't want you to call me every day, please, let's do container apps. To have a POC, to run it. And that's also valid, and that's also great. So just be aware that even if a technology is amazing, and Kubernetes is amazing, you still need to have the right experience and the people with the expertise to perform all these things, to have it actually running in production. Just know that. Keep that in mind. Green IT. Yeah. Okay. Adam Bean actually commented on that very well before, so keep that in mind as well. Thanks.
Anyone else?